Highest common factor. Johnny and Jenny are two friends. They love studying together. One day, Johnny brought two buckets of water. One measured 10 liters, another one 15 liters, and asked Jenny to do a task. The task was she has to get the largest container which can measure both the buckets and in exact number of times. So the task is she has to get the largest container and measure both the buckets in exact number of times. That's a good task. So Ginny first took the 10-liter bucket and thought how to measure it in exact number of times. So she thought she can take a 1-liter mug so that she can measure the bucket 10 times, or else she can take a 2-liter mug. If she takes a 2-liter mug, she can measure it 5 times, and if she takes a 5-liter mug, she can make it 2 times. And if she gets a mug of measurement 10 liters, she can do it in one time only. So these are the options she had. Now considering the 15-liter, the same thing. If she takes 1-liter mug, she can take it 15 times. If she gets a 3-liter mug, 5 times. If she gets a 5-liter mug, she can measure it in 3 times. 5 3s are 15, so in 3 times. And the last option is 15 liters. In one time only, she will measure the 15-liter bucket. Next condition, so remember is, but the thing is she has to measure both 10-liter and 50-liter. So she just sorted out which is present in both the options. Means in 10-liter also that is there, in 15-liter also it is there. So she gets 1-liter mug and a 5-liter mug are present in both the sets. That is, both are having 1-liter and 5 liters. The another condition was it should be the largest container. So since largest container among from 1 and 5, 5 is the largest one. So she gets it. So using the 5-liter mug, she can measure both 10-liter and 15-liter water. So here the largest container is 5-liter, which can measure both in exact number of times. So here the exact number of times is nothing but factor. Exact number of times, that is a factor, and measure both common, and the largest container means it should be the highest one. So it is nothing but the highest common factor. So the highest common factor of 10-liter and 15-liter is 5 liters. So let's read more about highest common factor. It is also known as the greatest common divisor, or GCD, HCF or GCD. So there are some few methods of finding out the HCF of two numbers, like prime factorization method, short division method, and long division method. Let's start with prime factorization method. Here, let's find out the HCF of 10 and 15. The same thing what Johnny and Jenny were doing the task, 10 and 15. Let's see whether 5-liter is the correct one or not here. So first thing, as per the name of the method, prime factorization method here. So it's a prime numbers you have to consider. Let's start with the factorization of 10 and 15. So we have to prime factorize it, means we can use only prime numbers. So let's begin. So 2 5s are 10, 3 5s are 15. Since we get prime numbers, we will stop it there. So 10 can be written as 2 into 5 and 15 can be written as 3 into 5. So here we have to find the common prime factors. So what prime factors are common in both? Remember, it should be in both. So 5 is common in both. So the HCF is 5. So the highest common factor of 10 and 15 is 5. So remember the steps. First thing is prime factorization. After that, finding the common prime factors. Common money in both it should be there. The same way, the largest container, measure both, and in exact number of times. So exact number of times means it is divisible exactly, means remaining as 0. So here 5 is the highest common factor. Let's take another one, HCF of 18 and 24. So 18 can be written as 2 times 9, that is 2 9s are 18, 3 3s are 9, 2 12s are 24, 2 6 are 12, and 2 3s are 6. So the prime factorization is completed. So 18 can be written as 2 into 3 into 3, and 24 can be written as 2 into 2 into 2 into 3. Now the next thing is finding the common factors. So 2 is common in both and 3 is also common in both. So what we'll do? So both the common factors will just multiply and get the HCF. So the HCF is 2 times 3, that is 2 into 3. So 2 is common, 3 is common in both. So we write 2 into 3 is 6. So the HCF of 18 and 24 is 6. Next, coprimes. Now what are coprimes? So two numbers which have no common factor. If two numbers are having no common factor other than 1 are called coprimes. Let's consider some numbers like this, like 3 and 5. So if we'll find out the factors of 3 and 5, we'll get the factors of 3 are 1, 3, and factors of 5 are 1 and 5 because they are divisible by itself and 1. If I take 3 and 8, 3 is 1 and 3, 8 becomes 1, 2, 4, 8. These are the factors of 8. 15 can be written as factors are like 1, 3, 5, 15, and the factors of 8 are 1, 2, 4, and 8. So here we see in all the three cases the common factor is 1. So they are called as co-primes. 3 and 5, 3 and 8, and 15 and 8 are co-primes. Here you have to see that co-primes need not be prime number. There is nothing linked that co-primes means it should be a prime number. As we see here, 3 and 8. Now 3 is a prime number, but 8 is not a prime number. And in the last case, 15 and 8, none of them are prime numbers. So it is not necessary for a co-prime to be prime numbers. So let's do the next one, that is sort division method. Let's find the HCF of 10 and 15 using this method. In this method, what we do, we take it together. So together we'll factorize 10 and 15. So 10 and 15 both are divisible by 5. So here you have to see that whatever the numbers you are taking, both should be divisible by a same number. So both 10 and 15 comes in 5 table. So 5 2s are 10 and 5 3s are 15. Here we will stop it as we are getting co-primes. Co-primes one, there is no common factor again. So 2 and 3 we cannot factorize it again because they don't have anything in common. So we'll stop it here and write down the common factor. So here the common factor is only 5. So HCF is 5. Similarly, let's find the HCF of 18 and 24. Now 18 and 24 both are divisible by 2 as they are even numbers. 2 9s are 18, 2 12s are 24, and we have 9 and 12. So 9 and 12 comes in 3 table. 3 3s are 9, 3 4s are 12. Now 3 and 4 are co-primes again because they don't have any common factor. They don't come in any table. 3 and 4 will never come together in any table other than 1. So we have to stop it here and note down the common factors. Remember, on the left side whatever we have, these are all common factors, and down what we have, this 3 and 4 are the other factors. So let's say only the common factors. So the HCF is 2 times 3, that is 6. So whether we use sort division or prime factorization, in both the cases we get the same answer. Let's say now let's find out the HCF of 3 numbers at a time. Now it's first we'll see is prime factorization method. So prime factorize 48, then 36 and 24. Now 48 is prime factorized, so 48 can be written as 2 into 2 into 2 into 2 into 3. And 36 can be written as 2 into 2, 3 into 3. And 24 is written as 2 into 2 into 2 into 3. So this is the prime factorization is done. Next thing is finding the common. So 2 is common, again another 2 is common, and here 3 is common. You see that whenever you are taking common, from each set only one we can take. Like you see in the first one I have taken 1 3, in the second set I have taken another 3, and third one another 1. Although in the 36 we have 2 3s, we can take only 1. So from each set one number will take. So the HCF becomes 2 2 3, that is 2 into 2 into 3, and we get 12. So the HCF of 48, 36 and 24 is 12. Now let's see the same thing using sort division method. Here, as the method says we have to take them all together. Now 48, 36 and 24 all should be divisible by a number. So that is 2 because all are even numbers. So 2 24, 2 8s are and 2 12s are. Again 24, 18 and 12 is divisible by 2. Again 12, 9 and 6 is divisible by 3. Here now we reach at a point where all are co-primes. Now 4 and 3 are co-primes, 3 and 2 are co-primes. So here we have to stop it because we cannot have any common factor of 4, 3 and 2. All 4, 3 and 2 we cannot have any common factor. So we'll stop it here and we'll proceed with the common factors. So the common factors are 2, 2, 3, that is 2 into 2 into 3 and we get 12. Here in short division method, the easiest part is we need not take only prime numbers as the factors. We can take composite numbers also, like 48, 36 and 24 comes in 6 table also. So 6 8s are 48, 6 6 are 36, 6 4s are 24 and we get 2 4s are 8, 2 3s are 6, 2 2s are 4. So here the common factors are 6 into 2, that is 12. But here you have to notice that we should be good at tables whenever we are doing that. And whenever you are using composite numbers, see that all the numbers are divisible by that. Whatever numbers are given to find out the HCF, all should be divisible. Or else here we can take 12 also, because 48, 36 and 24, all the three numbers comes in the table of 12. So 12 4s are 12 3s are 36 and 12 2s are 24, and that's pretty easy. So HCF is 12. So in all the three cases we get 12. Next, long division method. So let's find the HCF of 18 and 24. So in long division method, what we do? First, the bigger number is taken as the dividend and the smaller number is taken as the divisor. So 18 once 18, now the remainder is 6. After this, what is done? Once the division is completed and we get a remainder, after that the divisor of the previous step, here the divisor is 18, now it is made as the dividend. You can see that the 18, the divisor has been turned into a dividend now. So now 18 and 6 will be divided and we get 0. Once we get 0, we have to stop it there. Now how we got 0? When we are dividing 18 by 6. So 6 is the HCF. So the HCF of 18 and 24 is 6. So this is called as the long division method. Let's see some more. HCF of 20 and 28. Same thing, 28 is the dividend as is the bigger one, 20 is the divisor. 21s are 20, the remainder is 8. So again, here you see the divisor has become dividend. The divisor has become the dividend. So 8 2s are 16, the remainder is 4. Again 8 has become the dividend here. 8 was the divisor, now it is the dividend. So 4 2s are 8. Now you have to stop because you have got a remainder as 0 and the HCF is 4. So the HCF of 20 and 28 is 4. So here you have to remember, now to find the HCF of 3 or more numbers, what you have to do? So here first we'll find the HCF of any two numbers of our choice and then find the HCF of the third number and the HCF of these two numbers. HCF of the third number and HCF of these two numbers. So let's see, and the last HCF will be the required HCF. So this is like, suppose I have three numbers A, B and C. So first I will find the HCF of A and B. Then again I will find the HCF of this HCF and the third number. So the third number is C and the HCF of A and B, I will find out the HCF again and this will be the final one. Now for example, another number is also there. Suppose 4 numbers are there. Same thing. And the last HCF will be our required HCF. Just you have to keep on proceeding. How many numbers are there? Find the HCF, then find the HCF of with the third number. So keep on moving according to the number of given. So let's see here. Let's take three numbers 48, 160 and 252. Here we can take any two numbers, so our choice. So let us take 168 divided by 48. Let's find the HCF of 48 and 168 now. So 48 3s are 144, so the remainder is 24. Once we get the remainder, we can bring the divisor as dividend. So the divisor has become dividend. So 24 2s are 48, the remainder is 0. So here, as we get 0, the HCF is 24. Now we'll proceed. Now this HCF 24 and 252, we'll find the HCF again. 24 what we have got in the first case with the third number. So 24 tens are 240. Actually we can do in two steps also. 24 ones are 24, then 24 zeros are 0, whatever. So here 24 tens are 240. The remainder is now 12. As we have got the remainder, we can proceed with the change from divisor to dividend. So 24 was the divisor, 24 has become the dividend. Now 12 2s are 24 and we have got 0, so you have to stop it here. So the HCF becomes 12. So and 12 is the final HCF of 48, 168 and 252. Thank you and keep exploring.